Now let's look at generating a spiral using parametric equations on our CPU. Now first of all, I'm going to model it in the online graphical calculator called Desmos. So this file here is available to you in the resources section. You can open it up and have a look at it. Now the spiral is modelled parametrically as x is equal to t cos t and the y is equal to t sine t. So it's very similar to the circle. The only difference is that the cosine and the sine are multiplied by the value of t. Now the one that I've generated here, you can see it's actually it's quite small, but I think you can just about see it. It says t1 cos of t1, so that's the x coordinate, and then there's t1 sine of t1, so that's the y coordinate, and then it's scaled by a factor of 6. Now I've generated it here in Desmos so that it looks the same way it will whenever we put it onto our machine and plot it off. So in our machine we're only going to have individual points. So the points are going to start off at 5 pi by 30, and they're going to go all the way up to 5 pi, and they're going to jump at intervals of 5 pi by 30. So it goes 5 pi by 30, 10 pi by 30, 15 pi by 30, and 20 pi by 30, and so on and so forth. So it means that we've actually got 30 elements. So this is the plot here of the spiral. So we're going to start at this point here, and we're going to work our right way around the spiral and go all the way to here to the 30th element. So I've already loaded this into the machine and it's running now. So let's see what's happening. I have coded in the exact same parametric spiral that we've seen in the graphical calculator into our assembly language and then loaded it onto our machine. And you can see here it is still running. And you can see it's generating the points for the spiral. Now let's bring the spiral from the graphical calculator and we'll place them side by side. Now what I'll do is I'll make this a little bit bigger, and I'll bring this one up. And you can see here, if we make a comparison, that they are almost exactly the same. So you can see each of the points here, point 1 there, that's the first point here, 2, 3, 4, 2, 3, 4, and so on and so forth. And if you follow these points all the way around, you can actually pick the point where we're at the moment. So we're actually at this point here, which looks like it's probably this one. So we're at this point here at the moment. So the next one's going to be heading down here. So you can actually pick out roughly where it's going to be. So that means that it's a good check on the accuracy of our CPU, and it shows that the spiral code does work. So let's go ahead and I will open it up and show you the code. So here is our assembly language code. I've put a little note here on how we've generated the spiral. It's going to be 6t cos t, 6t sine t, and t is the parameter from 0 to 5 pi, and we're going to have 30 points, and they're going to be evenly spaced 5 pi by 30, and that's exactly what we've seen in the online graphical calculator. So we're going to first of all push the value onto R3. So this is the first value, which is actually 0.52359 in radians. And we're going to, in effect, that's our parameter t. And then we're going to generate the cosine of that. So we will end up with R0 equaling the cos of t. And then we're going to put the value of 6, which is the amplitude that we're going to multiply by, and it's going into register R1. And then we're going to push both of those values in to the multiplication for the fixed point, and that's going to give us the 6 cos t. And then we have to multiply that by the value of t, so we're going to push that and the t into the next multiplication, and it's going to give us the value r0 is t 6 cos t. So that in effect is the x coordinate. And then we're going to go through the same thing again, but for the sine function, and it's going to give us the value r1 is equal to t 6 sine t, and that's the y coordinate. And again, we're going to have to do the decimal to integer conversion and the rounding so that we can plot it, and we do this here for the y coordinate and then the x coordinate, and then we're ready to plot the points. So we can push r0, r1 and the colour onto the stack, call the subroutine for the plot, and it will run through and plot the point. We then decrement the index register, so the index register is sitting at a value of 30, so I set this up here. So the index register has got a value of 30, and then what we're going to do is we'll take one off because it's run through this once. We'll compare it to the value of 0. If it's equal to 0, the program ends. It just jumps to program end. Now if it isn't equal to 0, we're going to add the next law on. So we're going to add on another 5 pi by 30, which is 0.523598, and then jump back to the beginning of the loop again. So we'll go back here again, and it generates the next point. So it will continually do that until the counter for the index register has gone down to 0, and that will be the end of the code. So let's quickly go back in and we will have a look and see how far along the simulation has come now. So the CPU is still running, and it's got about another 8 or 9 points to generate. But you can see that it does model quite precisely what we have within the graphical calculator. So that's our parametric spiral. There's lots and lots of things you can do with parametric equations, and it's really just limited by our own imaginations. So thank you for listening. I'll get you on the next video. Goodbye.